Alright, hello. This is a tutorial on how to use the software to segment the pipette tips, whether required using the Canon optical system or the iPhone system. Both will use the same segmenter. So, as was noted in previous tutorials, it's the same segment, same software, but in the acquisition tab, since you're no longer connected to a camera, it will show an error. Doesn't matter, the segmenter tab will still work and all the functionality therein. So I'm going to be doing the tutorial with a couple different data sets, all of which are available on the website in the example data folders. There's several options for the segmenter regarding whether or not prior processing should be overwritten. Examining the experimental plate map after segmenting, this will just produce a heat map at the end showing the relative colony density in the different wells. This option allows you to apply a segmentation model during the processing. This will run fast because it's run in parallel, and I'll talk through what are the different segmentation models available. And then finally the option to use parallel processing. This requires more memory but is faster. If you're finding that the program is crashing, it's likely that you're running out of RAM, and so unchecking this might be a solution. So after I've selected my experimental data, set up my imaging parameters. So for this particular one, it was acquired on the Canon camera with 3 pipette tips per field of view. And I've set the experimental configuration. Click process data, and this is going to pop up with a question box that asks if you want to proceed. The reason for this is the way the code currently is configured is it looks for, in the current directory, recursively, folders containing JPEGs. So if your folder has, say you picked the documents or the pictures folder on your computer, and it has all your GVA pipette tips, but also hundreds of folders of cat pictures, this will not be able to distinguish which ones are GVA pictures, and so right here you would see some crazy number of, you have 42 folders with JPEGs. If that does not sound correct, then you need to navigate into a more specific directory. One of the nice things about this configuration is that if you've run a large screen, you have lots of plates, they're each in their own folder, you don't have to navigate into each one individually, you can process them all together. So at the directory at the head of it will look through all the folders and find JPEG folders. So here I'm going to proceed. Since I've already processed the data, it shows up with my prior processing. The circles indicate the colonies, the red line indicates the end of the tip. Now to interact with this, there are a convenient table of hotkeys that are all the different actions you can use. So for example, if I want to add a colony, I have a left click, enter takes me to the next picture, P takes me backward. If you want to skip to a specific well, you press S. This allows you to go to, say, A2. If you think that the pipette has an error, so there's large bubbles in it that will prevent counting, you press E, and this will just put a NaN value for the CFUs there. Backspace removes the last added point. Delete removes all the points. X removes the closest point to the cursor. T moves the tip end, so if the tip, the automatic tip finder algorithm didn't work, you can place your cursor at the correct position and press T. R removes all the colonies to the right of the cursor, so if I press R here. Conversely, L removes all colonies to the left of the cursor. L. M sets the upper limit of detection, so the first time on a specific plate that you press M, say that you know that there are colonies in the tip, but they're too dense to count, you'll press M and it'll come up with what is the upper limit of detection, and this must be the user defined, and it must be a numeric. So for most of the bacterial assays, you'll find 1 times 10 to the 9 is probably the upper limit of what you can reasonably count. So I click OK, and now from now on, whenever I press M, it will auto fill that well as the maximum value. That's the upper limit. Z is the only command that's slightly different, whether you're using the compiled app or the source code. So on the compiled app, when you press Z, it's going to open up a little message box that says press OK when you're done zooming. This gives you a little zoom bar that allows you to scroll in and out and zoom, and then when you're done, you click OK. On the non-compiled version, that message box will not pop up. You'll just be able to zoom in and out and then press any key to finish. F tells the computer that you've finished counting the plate, and it will pop up that heat map, as was said before. So these are the 2 wells here. This was 1 row of all 12s of the same condition. You can see the 2 that we pressed M for went to the maximum value, which was 1 times 10 to the 9. These values in heat map are done in log space. If you're looking at this and you think that something is wrong with that well, you hover the mouse over it and you can click on it and it will pull you back to that well. You can say, yes, I clearly did not count this one correctly. And when you recount it, and click finish, there we see the correct value now. Just like S allows you to skip between different wells, D allows you to navigate to different directories within all the process data. And then the zoom and segmenter model shortcuts. So the zoom models are helpfully coded 1, 2, 3, and 4. 1 is the whole pipette tip. 2 is about half the pipette tip. 3 zooms into the last 1/8 of the pipette tip, and then 4 is the absolute end of the tip. These different zoom models just are hotkeyed to allow you to go move in and out quickly without pressing zoom. Additionally, the segmentation models, which will take a guess at the correct segmentation for your colonies, are 5, 6, 7, 8, and 9. 5 segments the whole pipette tip and looks for big colonies. 6, which is what I would say this is approximately, looks toward the last third of the pipette tip. 7, the last, and so on down the line. So for this one, if I clicked 5, it's running the segmentation. We can see that the colonies were too small for the 5 and it did not catch them very well. If I press 6, this looks like a good segmentation and it's in a contiguous region, so that I would believe this value. 7 does pretty well, although it starts picking up some of these background pieces because it's more sensitive. 8, now this one clearly has lots of background on it, but we could fix this by using the commands of moving everything to the right and left, and then adding the colonies back in. And then 9 is all the way at the very tip. So an important thing about counting, when we begin counting these colonies, is that the math only cares about the position of the first colony from the tip, so that would be this one, the position of the last colony from the tip, that would be this one, and the number of them in between. It does not care about their position in between. So for example, if I was counting this So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 colonies. The value here, 2.3 10 to the 6th, is the exact same as if I just picked my first and last colony and then put 8 points in between for a total of 10. 4, 6, 7, 8. So mathematically, it doesn't care where the positions of the middle colonies are in that way. So here I'm going to apply the 6 model. Now, since I'm going to skip back to the first well, I'm going to apply the 6 model here. Since all of the pipette tips in this experiment are similar conditions, meaning the same density of CFUs, if you've clicked a segmentation model and you found that works well, you can click all, and this will segment the rest of the plate using that model. So if I click A, it's going to pop up a box telling us that it's segmenting with model 6. And now if I look at the finished plate, they're all roughly the same. And I can navigate to ones and see how the colony segmenter did. Pretty good. Missed maybe one there, etc. To personalize the segmentation model, here's the colony segmenter configuration. So it tells you what is the current model you're using. So if I click 6, in the blue outline, it outlines the pipette tip eroded with a tip mask. So this tip mask is a 10 right now. If I wanted to erode less, I could lower that number, say to a 2. This must be a positive number though, or increase the erosion. If I wanted to erode less of it, I could go bigger. Also gives you the option to measure the colony pixel size, so you can zoom in. And it'll give you an answer of what's the diameter in pixels, about 16. The default for this model, I believe, is a 10. You can see you're catching or losing various changes. Sensitivity, similarly, is just how sensitive the segmenter is to finding colonies. So at the very low end, for these ones in particular, it's easier to capture all the cells, or all the colonies. It's very insensitive to sensitivity. Alright, so after I finished with my segmentating, I can push F for finish, and F again. And now that data has been written to the experimental folder. So what this looks like is in this folder where the data was located, I included, before I began counting, a well treatments file. This file just gives basic information as to the well, sample, and then the information on what's in each well. This can be drug information, this can be strain information, etc. All that is required is to have this well column that has A01 all the way through A12, B01, etc. And this will then merge with the colony counts to produce this CFUs per condition file. So to open this, let's see. And this will now have the well, the CFUs that were in that well, number of colonies you counted, and then the information that was in that well treatments file. If you do not have the well treatments file before you finish counting, it will not it will just produce a file that has the well, the CFUs, the number of colonies counted, and then what folder it was done in. Additionally, in that folder is also the plate map figure. This just lets you see that heat map of the wells. And then it also saves the segmentation parameters that were used. So if you find that you have some model that is working really well, then at this step, if you wanted to apply that model at the prior processing, you can click select parameter file, and you can navigate and load this one in, and then it will update what the defaults are for the colony segmenter. Alright, so now I'm going to show slightly different data involving yeast dilutions. If I click process data, proceed. So now we can see this has very, very dense colonies, and at this high end of the dilution series, it's actually so dense we can't make out individual colonies particularly well. Perhaps we could count these in here. There's kind of a bubble in the way though. So for this one I will just put it's at the maximum. Okay, you can see here that I did count these colonies, and that the value of these counted colonies is about 6 times 10 to the 8th. So as I click through, you get a sense of how the colony sizes change as a function of the dilution. So here's an example of small bubbles, which might have inhibited counting, but I found a good region to count in, and the value was approximately what we expect. So you could still count this pipette tip if the bubbles aren't precluding your ability to count. You will have some error due to changes in volume, but they can be overcome just by the amount of information encoded in the position of the colonies. So now the colonies are bigger and easier to find as you go down and dilute more and more dilutions. So if I click finish on this one, you can see the dilution series goes from 10 to the 9 all the way down to the limit of detection. So for these ones out here, no colonies are in the pipette tip, and the segmenter automatically, instead of putting a 0 here, which then creates negative infinities, it just sets it to half the limit of detection, which is determined based on the dilution that you put in there. So after I click finish there, last experiment to examine, we'll look at iPhone data, bacterial dilutions. So now if I click process data, you can see the pipette tips taken with an iPhone image, scan forward to rows that were actually countable. So this is an image taken with an iPhone. So if here the pipette tip position is not quite correct, so if I move it forward, see how this changes the CFU. It goes from 3.55 times 10 to the 5th to 3.15. So very small changes despite being up to almost a millimeter off in the tip colony. So I think that's all relating to the segmentation software. If you have questions, please of course email us at gva.help@gmail.com, and we look forward to accelerating research and happy CFU counting.